Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am.
Good evening. Kindly turn on your videos. I was just waiting for the others to join. Looks like we have to change the time to 6:30 to 8. We'll see. We'll talk about that later. Devadarshini, please disable your mic. Is my screen visible, children?
Yes, ma'am.
Yes, ma'am.
Am I audible?
Yes,
Clear?
ma'am.
Very good. Very good. So, from my understanding of the last class, I think about 50% of the class has not, maybe may have watched but not thoroughly understood the concept in the concepts in the chapter polynomials. So I don't want to go ahead with that. So we were doing number systems. I just wanted to check as to how much you've understood from the videos. But looks like some of you have to rewatch the videos to understand the contents of the chapter better. So let me give you some more time because we have many interesting papers to solve. And if those papers, those questions have to be interesting for you, you should have understood, learned the chapter clearly. Then it will be interesting. Without having understood the concepts clearly, it will be interesting only for those who know it well. So I'll give you some more time, children. Maybe next Tuesday, I'll update on WhatsApp as to what you have to do. So we'll resume with polynomials next Tuesday. So now today's session, we are going back to the first chapter, number systems. Exponents is a part of number systems. It's the last part, the concluding part of number systems. Exponents. Exponents is the concluding part of the first chapter, number systems. So we'll see some interesting sums from exponents today. Yeah. So I want you all to take screenshots and complete the classwork later. We're just going to understand in today's class. I'm not going to give you time to write in today's session. Let's understand, take screenshots and complete the classwork later. All right. So under simplify, the first question, under simplify, we have 12 subdivisions. Let's take up the first one. Simplify, we have 12 subdivisions. Let's take up the first one. So 3 to the power 1 by 2 into 3 to the power 1 by 3. Who can tell me how to simplify this? Bases are same, right? Bases are same and it's multiplication. So what will you do?
We should add the powers.
Add
the powers.
Add the powers. Go down to 8th standard. When bases are same and it's multiplication, we add the powers. When bases are same and it's multiplication, we add the powers. Here the base 3 and it's multiplication. When bases are same and it's multiplication, we add the powers. So the answer is write the base ones 3 and add the powers 1 by 2 plus 1 by 3. All right. Here. This is the question. Bases are same and it's multiplication. So we add the power. So you can see here 1 by 2 plus 1 by 3. Write the base only once. 3 is the base. Write it only once. Add the powers. And then you know LCM is 6. You know how to add fractions 1 by 2 and 1 by 3. So 3 to the power 5 by 6. 3 to the power 5 by 6. All right. Can we go to the next one? Take a screenshot.
Yes, ma'am.
Yeah. Now here bases are different. but the powers are the same and its multiplication. Bases are different, but the powers are the same. See, very important, the sign, the two terms are connected by a multiplication sign. The rule is a to the power m into b to the power m. Bases are different, a, b, it's multiplication, but the powers are the same. M is equal to a into b, the whole power m. This is the rule. This is the rule. If you want the rule for the earlier one, a to the power m, a to the power m into a to the power n is equal to a to the power m plus n. Bases are same. In the first one, bases are same. A, it's multiplication. We add the powers. You can see there, m plus n. That's the rule for the first one. Maybe you can take a screenshot again.
Taken, ma'am.
Second one, I'll write it again. In the second one, so in this one, bases are different. See, there are 2, 3. So I'm writing A, B. I'm writing A, B. Bases are different. It's multiplication and the powers are the same, M, M. Bases are different, multiplication, powers are the same. A to the power m into b to the power m is equal to a into b or simply ab to the power m. This is the rule. This is the rule. To see the answer? The rule is a to the power m into b to the power m is equal to a into b, the whole power m. So 2 into 3, the whole power 5 by 8, which is 6 to the power 5 by 8. Multiply the bases and raise it to the same power. Do we understand the rule?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right, children. Screenshot. All right, children, please take a screenshot.
Taken, ma'am. Taken, ma'am.
Done, ma'am.
So this one we have seen earlier. Who can answer this?
Add the powers.
Are the bases the same?
Yes, ma'am.
Yes, ma'am.
Multiplication?
Yes.
Yes, ma'am.
So we need to add the power.
Add the powers.
625 to the power 0.16 plus 0.09. What is 0.16 plus 0.09? 5, 1 carry over 0.25. So 625 to the power 0.25. And how do you express 0.25 as a fraction? 25 by 100.
25 by 100.
25 by 100, 1 by 4. 25 by 100 is 1 by 4. So it's not, the steps are in the next slide, children. So it is 625 to the power 1 by 4. And what is 625? 5 to the power 4 into 1 by 4. 625 is 5 to the power 4. 625 is 5 to the power 4. Let me write it like this. 625 is 5 to the power 4. The whole power 1 by 4. What do we do with the powers? We multiply the powers. 4 into 1 by 4. We multiply the powers. 4 and 4 cancels out. 5 to the power 1, which is 5. Shall I do it again, children?
Yes, ma'am.
No, ma'am, it's clear.
Yes, ma'am.
Clear, ma'am.
Okay, once again, quickly. Bases are same, multiplication. So we need to add the powers. 625 to the power 0.16 plus 0.09, according to the law of indices or law of exponents. Indices, exponents, indices, exponents, law of exponents or indices. So it is 625 to the power 0.25. 0.25 is nothing but 25 by 100. 25 by 100 is nothing but 1 by 4 on simplifying. 625 can be expressed as 5 to the power 4. And there's already this power 1 by 4. So the whole power 1 by 4. Now these two powers have to be multiplied. 5 to the power 4 into 1 by 4. 4 and 4 cancels out. 5 to the power 1, which is 5. So the value of the given expression is 5. Children?
Taken, ma'am.
Taken, ma'am.
All right. Exactly what I've explained is here. So don't worry about anything. So here, Arjun, Jayant. Just a second, children. Just a second. Yeah, children. So again, simplify. 2 to the power 55 into 2 to the power 70 minus 2 to the power 153 into 2 to the power minus 28. So here you need to, the brackets are not there, but you need to enclose you need to enclose the terms correctly inside brackets. So like if you have 5 into 4 minus 6 into 5 like this. So you need to perform 5 into 4. You need to perform 6 into 5. 5 fours are 20. 6 fives are 30. Subtract minus 10. This is what you'll be doing. If suppose there's a question where there is no bracket, there is 5 into 4 minus 6 into 5. Then you will do the multiplication first. You will put brackets like this. You will multiply 5 fours are 20, 6 fives are 30, minus 20 minus 30 is minus 10. The same thing is what we're going to do here. Enclose the first two terms in a bracket and the last two terms in a bracket. And you can see now you will have to find this product. You will have to find this product and subtract the products. Am I audible and clear, children? My screen is visible.
Yes,
Yes,
ma'am.
ma'am.
Yes,
ma'am.
All right.
Yes, ma'am.
All right, children. So it goes like this. As I told you. So now how do you handle the first part? How do you handle this? Bases are same, it's multiplication. So we have to add
Add the powers.
Add the powers, ma'am.
2 to the power 55 plus 70 minus, what do you do with the second part? Again, the same rule. Bases are same, 2, 2.
We
It's
need to add the powers.
We need to add the powers. 153 plus minus 28. Or you can write minus 28 straight away. You can write minus 28 straight away or 153 plus, because you'll have to add the powers. So 153 plus, why plus? Because you'll have to add the powers, plus minus 28. So next step is 2 to the power 125 minus 2 to the power, what is this, 153 minus 28, right? Minus 28, you all understand that. So this is also 125. On subtracting, you get 125. 2 to the power 125 minus 2 to the power 125. What is 10 minus 10?
0.
0, ma'am.
So something minus the same thing is 0. This is something and this is the same thing. So what's the answer?
0.
0.
No, because
0, ma'am.
the two quantities are the same. The difference of two same quantities is 0. 10 minus 10, 0. 5 minus 5, 0. 4 minus 4, 0. So we have 2 to the power 125 here. We have the same thing here, 2 to the power 125. What is their difference? 0. So the answer is 0. Yes, children, go through the slide. Go through.
Yes, ma'am.
Yeah. All right, children. Next one. So there are, two ways of writing expressions. So we have the exponential form. We have the exponential form. We have the exponential form. And we have another one called the radical form. Radical form. When I write something like this, 5th root of 3, this is in the radical form. If I have to write the same thing in the exponential form, it is 3 to the power 1 by 5. Supposing I have the 11th root of 7. 11th root of 7. That's the radical form. This expression is in the radical form. This expression is in the radical form. 11th root of 7. Exponential form. 7 is the base. 11th root becomes 1 by 11 to the power 1 by 11. 7 to the power 1 by 11. Exponential form, radical form. These expressions are in the radical form and these are their corresponding exponential forms. So what is the exponential form of square root of 23? What's the exponential form?
23.
23, ma'am.
1 by 2.
1 by 2, ma'am.
23?
By 2.
The power 1 by 2.
To the power 1 by 2. Yes, right. Because when we say square root, there is a 2 there, but we don't write because when there's nothing, it's default 2. Like when you write 5, it is default a positive 5. If it's minus 5, you should write minus 5. You can't write 5 and say it is negative. If you write 5, it is assumed to be positive. Similarly, we read this as square root of 23. So here there is 2. We don't write it. We don't write it. Square root itself means there is 2 here. So it becomes to the power 1 by 2. 23 to the power 1 by 2. And supposing we have cube root of 35. This is the radical form. Exponential form. 35 is the
35 to the power 1 by 3.
This one becomes the base. And the reciprocal of this becomes the power. 3, 1 by 3. 3 becomes 1 by 3. It's not 35 to the power 3. That will become 35 into 35 into 35. It's not 35 to the power 3. It's 35 to the power 1 by 3. No, I'm pausing so that you like work it in your mind and understand. So supposing we have say x square, the 5th root of x square. this is the base. This one is the base. Write that as this. This is the base. The reciprocal of this is the power. The reciprocal of that is the power. So it's simple. We're using the same idea everywhere. Am I right, children?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
This as it is becomes the base. This is the base. The reciprocal of this is the power. Okay, now another one. Now supposing we have x to the power 11 by say like 23. Now how do we put this? This is in the exponential form. This is in the exponential form. This is in the exponential form. So how do we put it in the radical form? So for that you need to write 11 by 23 as 11 into 1 by 23. 11 into 1 by 23. And this becomes x to the power 11, the whole power 1 by 23. Because when two things are multiplied, it's like this, x to the power 11, the whole power 1 by 23. 11 into 1 by 23. So now it becomes the 23rd root of x to the power 11. The 23rd root of x to the power 11. Maybe you can make a note of this. Let me write this again. Somewhere you can just put a cloud and just write it in a cloud. Just put a cloud and write it in it. Make a big cloud and write it inside the cloud. So I said x to the power, sorry. So I said x to the power 11 by 23. First step, this is in the exponential form. We want to put it in the radical form. So x to the power 11 by 23 is equal to x to the power 11 into 1 by 23. 11 by 23 is equal to 11 into 1 by 23. So x to the power 11 into 1 by 23. That is equal to x to the power 11, the whole power 1 by 23. This is nothing but the 23rd root of x to the power 11. Kindly make a note of this.
Yes, ma'am.
It's under exponent, or you can take a screenshot and write it later if you feel there is no continuity, no? You can take a screenshot, write it later, yeah. Now let's come to the question. The fourth root of the cube root of x square. The fourth root of the cube root of x square. That's how you read it.
Ma'am, is it x square the whole cube the whole power 4?
1 minute, one by one, 1 second. So it's the fourth root of the cube root of x squared. All right. Now we'll start removing the radicals from outside. So yes, the fourth root of the cube root of x squared. So now first let's remove this. You can do it in two ways. I don't know how I've done it in the slide. I'm just explaining it like this. I'm removing this. So if I remove this, it will be cube root of x square, the whole power 1 by 4. Am I right?
Yes,
If
ma'am.
I remove that fourth root, then all this will remain. All this will remain to the power 1 by 4. This becomes the base, and that fourth root will become 1 by 4. Yes or no? Now I want to remove the cube root. How do I remove the cube root? So this becomes, don't write anything, children. So this becomes x square. I'm removing the cube root. I'm removing this. So it will become to the power 1 by 3. But there's already that power 1 by 4. Don't forget to write that. Now this is multiply all the powers. Multiply all the powers. X to the power 2 into 1 by 3 into 1 by 4. Cancels x to the power 1 by 6 because 1 into 1 is 1, 3 to the 6. Let's do it again. Let's do it again. 4th root of the cube root of x squared is equal to, I'm removing this first. So I should raise it to the power 1 by 4. If I'm removing the 4th root, it will become to the power 1 by 4. Whatever remains is the base. So it is the cube root of x squared. That is the base. Now next I'm going to remove this cube root. So whatever remains, this one is the base x squared. That cube root will become to the power 1 by 3. But there is already the power 1 by 4. So to the power 1 by 4. Now when a base is raised to multiple powers, we need to multiply the powers. There is one base x. It's raised to many powers. So you need to multiply the powers. X to the power 2 into 1 by 3 into 1 by 4. 2 ones are 2 twos are. You can see 1 in the numerator everywhere. So 1 into 1 into 1 is 1. In the denominator, we have 3 into 2, 6. So that is x to the power 1 by 6. Take a screenshot, children.
Done, ma'am.
All right. Okay, so I think I've done this in one shot. I didn't show all the steps I showed you. I've done it directly here. Okay, let me write this alone for you. This alone, please take a screenshot of this one. Let's show all the steps. Please take a screenshot of this one, children.
Taken, ma'am.
All right.
Done, ma'am.
Yes, all of you find the prime factors of 243. Rough work. You can use a rough notebook for today's class. Yes, or maybe behind your tuition notebook. Find the prime factors of 243.
Ma'am, it's 3 to the power 5.
Yes, ma'am. I have answered.
All of us are getting the same thing.
Yes, ma'am.
All right.
Yes, ma'am. Yes, ma'am.
Very good. So 243 divided by 3 is 81. Divided by 3 is 27. Divided by 3 is 9. Divided by 3 is 3. Divided by 3 is 1. So 3 to the power 5. Okay. So how do you write cube root of 3 in the exponential form?
3 1 by 3.
3 to the power 1 by 3. How do you write fourth root of 3 in the exponential form?
3 power 1 by 4.
Power 1 by 4.
How do you write 12th root of 243 in the exponential form?
3 to the power
3.
5, the whole power 12, ma'am. 1 by 5. The whole 3 to the power 5 to the whole power 1 by 12.
Okay, so we'll write 3 to the power 5 in the next step. So it will be 243 to the power
1 by 12.
1 by 2. You can
1
write
by
3 to the
12.
power 5 here straight away. You can write this straight away. 3 to the power 5, the whole power 1 by 12. That's fine. You can write that. So I'm not simplifying here. I'm not simplifying here. I'm just writing it as it is. So into 3 to the power, you can just do that in the rough work. 3 to the power 5, the whole power 1 by 12, right? So it will be 3 to the power 5 by 12. Rough work, rough 243. How did you get 243? 243, 381 times, 327 times, 9 times, 3 times, 3 once. So 3 into 3 into 3 into 3 into 3 is 3 to the power 5. 243 is equal to 3 to the power 5. So 243 is 3 to the power 5. And there's already that power 1 by 12. So it is 3 to the power 5 into 1 by 12, which is 5 by 12. 3 to the power 5 by 12. Now bases are same. 3, 3, 3. It's multiplication. So we need to add the powers. 3 to the power 1 by 3 plus 1 by 4 plus 5 by 12. And that's it. You'll have to take the LCM and find the answer. So let me show you the steps here. Please go through every step. So whenever we have powers like this, 5, 1 by 12, we multiply the powers. 5 into 1 by 12. Multiply the powers. 5 into 1 by 12 is 5 by 12. 5 into 1 by 12 is 5 by 12. So that's what you see here. 3 to the power 1 by 3, 3 to the power 1 by 4, 243 is 3 to the power 5, and 12th root. So it will become to the power 1 by 12. 3 to the power 5 because 243 is 3 to the power 5. And the 12th root becomes 1 by 12. Next one. Cube root of 250 plus 7 into cube root of 16 minus 4 into cube root of 54. Yes, children, try this. Just give me 2 minutes, children. I'll get back. Please try this. Yes, children. What's that you're getting? Yes, Krishmika, Shri, Rajit, Tanishka, Netra, Sanjay, Sindhu. I can see only these people. I can't see the others. Yes, children. What have you got? Yes, Madhumita, Arjun, Jayant. We'll do it together. You want me to give you some more time or we'll do it together?
Ma'am, we'll do it together.
All right. So let's do this first. Tell me.
2 into 5 to the power 3.
Oh, okay. You're saying the final answer. Okay,
Yes, ma'am.
correct. So 2 125 times, 5 25 times, 5 5s are 5 1s are. So 250 is equal to 2 into 5 to the power 3. Correct?
Yes, ma'am.
Okay. So cube root of 2 into 5 to the power 3. 250 is 2 into 5 to the power 3. See here, you can see it here. Next, 16. 16 we all know, right? 2 to the power 4. 16 is 2 to the power 4. We all know that. So plus 7 into cube root of 2 to the power 4. Children, please tell me, are you following?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, we are writing 250. We find the prime factors of 250, and 250 is 2 into 5 to the power 3. That's instead of 250, we have written 2 into 5 to the power 3.
Yes, ma'am.
Instead of 16, we have written 2 to the power 4. Now minus, we are writing the rest as it is. 4, see that 4 as it is 4. That cube root symbol as it is. This number 54 we are going to change. 54 is 54, 2, 27 times 3 9s are 3 3s are 3 1s are 2 into 3 cubed. 2 into 3 cubed. 2 into 3 cubed. So what have we done? We have written 250. We have written 250 as 2 into 3. Rajat, Giant, okay. Giant, now kindly disable your mic. Thank you. Yeah, so 250. 250 is written. See, you can see that cube root symbol as it is. You can see here. Cube root as it is. 250 is written as 2 into 5 to the power 3 or 5 to the power 3 into 2. Both are the same. Then this one, see the 7 as it is plus 7. You can see plus 7 as it is. This cube root also, you can see that cube root symbol as it is cube root. 16 is written as 2 to the power 4. Similarly, minus 4 as it is, minus 4 as it is. This cube root symbol also as it is. 54 is written as 2 into 3 cubed or 3 cubed into 2. So let me write it neatly again. So it is cube root of 2 into 5 cubed plus 7 into cube root of 2 to the power 4, which can be written as 2 into 2 to the power 3. Because we are under the cube root symbol. Okay, fine, no problem. I'll write 4 only. Okay, so cube root of 2 to the power 4 minus 4 into cube root of 2 into 3 to the power 3. Now what will happen? How will you get rid of the cube root symbol? From 5, from 3 5s, 1 5 will come out, correct? How many 5s are there under the cube root?
3 5s, ma'am. So
3, ma'am.
3 5. So 1 5 will come out of the cube root. Now what remains under the cube root?
2, ma'am.
So cube root of 2. Don't forget to write cube root of 2. Don't write 5 and 2 like this. This is wrong. The simplest, the radical is cube root. Cube root of 2 into 5 cubed. So how many 5s are there under the cube root? 3 5s. So 1 comes out. What remains under the cube root? Only 1 2. So 5 into cube root of 2. Plus 7 into, how many 2s are there? 4 2s.
Oh.
But there are 3 2s, right? So 1 2 will come out, correct?
Yes, ma'am.
From 3 2s, 1 2 will come out of the cube root. So how many 2s will remain under the cube root?
1 2, ma'am.
1 2 will remain under the cube root.
Yes, ma'am.
Children, see here, children, this plus I've written as it is, this 7 I've written as it is. 2 to the power 4 is nothing but 2 cubed into 2. So from 3 2s, 1 2 will come out of the cube root. See here, out of the cube root. And what remains under the cube root? This 2 will remain under the cube root. Minus 4, 3 3s, 1 3 out of the cube root. See, I've written outside the cube root. And what remains under the cube root?
2.
Yeah.
2.
Now we have 5 cube root of 2 plus 14 cube root of 2 minus 12 cube root of 2. They're all like surds. Like we say like terms. What will you do with 5x plus 14x minus 12x? Do the same thing here. What is the, okay, you all tell me the answer for this one. What is 5x plus 14x minus 12x? Tell me the answer for this. Why x? Because everywhere cube root of 2, cube root of 2, cube root of 2. What's the answer for this?
7x, ma'am.
7x. So what should I write here? For x, what should I write here? 7.
Cube root.
Cube root of 2, ma'am.
Cube
Cube
root
root
of,
2.
say that confidently, children. Cube root of 2.
Yes,
This is like that x. Like surds. They are like surds. Like terms. Like terms. They're like surds. Everywhere. Cube root of 2. Cube root of 2. Cube root of 2. Like 5y plus 14y minus 12y is 7y. So here it is 7 cube root of 2. Okay, I have done my part, children. I'll give you 2 minutes. Relax and go through every line. Don't be in a hurry. Don't, you know, okay, she's going to change the slide. So let me just do it quickly. No, don't do that. Do it slowly. I'll wait. If you want me to wait, I'll wait for you. See that prime factorization and all you should do in the rough column, children. All that I have not shown here. So suddenly if you think how did you write all this, that you should know. You must do all this in the rough work. 250 is 2, 125 times 5. All this you should do in the rough work. Done, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Second, ma'am.
Yes, ma'am.
All right. So it's a similar one. I'm not explaining this. Go through. I'll give you 5 minutes. Go through the answer.
Understood, ma'am.
Okay. I'll wait for some more time for the others. So these will get cancelled. 2, 2, 3, 3, 4, 4, 5, 5, 25, 8 5s are 40, 3, 15 2s are 30. So children, now you will think, why you've written 25 square? Why did you not write 5 to the power 4? You can also write 5 to the power 4. We'll do this here. What if I write it as 5 to the power 4? 5 to the power 4 to the power 1 by 2, correct? So it will be 5 to the power 4 into 1 by 2. So 2 1s are 2 2s are. 5 square is 25. You will get the same answer. See, don't think. Yep. I've written 25 square because I can directly cancel the 2 and 2. You can also write 625 as 5 to the power 4. The whole power 1 by 2. The whole power 1 by 2. So next step you'll get 5 to the power 4 into 1 by 2. 2 1s are 2 2s are. So 5 square, which is 25. So you'll get the same thing, 25. You can write 625 as 25 square or 5 to the power 4. 625. 5 125 times, 5 25 times, 5 5s are, 5 1s are. You can write it as 25 squared or 5 to the power 4. Why 25 squared? 5 5s are 25. 5 5s are 25. So 25 squared. Or 5 to the power 4, whatever. So we'll do an alternate method of working this. Here I've written everything in the exponential form and I've worked it. You can also do it like this. So it is the square root of 5 to the power 4. It's the square root of 5 to the power 4 minus 8 into cube root of 5 cubed plus 4th root of 3 to the power 4 plus 15 into 5th root of 2 to the power 5. $625 is 5 to the power 4. 125 is 5 cubed. 81 is 3 to the power 4. 32 is 2 to the power 5. You can also do it like this. So what will be the next step? There are 4 5s under the square root. Okay, 4 5s. So 2 5s will come out because 4 5s means it's like 5 square and 5 square. Okay, or you can think like this in the rough column 5 into 5 into 5 into 5 it is. So from these two 5s, 1 5 will come out. From these two 5s, 1 5 will come out. So 5 square comes out. Comes out of the square root. There are 4 5s. From two square root, no? So from 2 5s, 1 5 will come out. Minus 8 into under the cube root, there are 3 5s. So 1 5 will come out. Plus 4th root as it is. See that 4th root. So from 4 3s, there are 4 3s. 3 into 3 into 3 into 3. 1 3 will come out. Plus 15 into how many 2s are there?
5.
So there are 5 2s and 1 2 comes out of the 5th root. So this is nothing but 25 minus 40 plus 3 plus 30. And 25 minus 40 is minus 15. Minus 15 plus 3 is minus 12. Minus 12 plus 30 is 18. So the difference is here I've put everything in the exponential form. Here, as it is with the radical form, we have proceeded. You should do it in both the ways. You should practice both the ways. And when you're working all this, you should give your full, you know, your mind must be completely into this work, because you don't know if you can, you know, work all this again before the exam. There's so much to practice. Each and every sum you cannot work before the exam. So simple concepts like this, when you work it like this, maybe once only you can do all these sums, because you, as we proceed, you have so many other things to, you know, learn and understand. So all this, when you're doing it for the first time, put your full mind into it, understand it clearly, make sure that you don't have to repeat this at all. You will always remember. Take a screenshot of this one also and do it in both the methods.
Taken, ma'am.
All right. So see,
Taken.
yeah, the effect is going to be like this. Now we are discussing, and you know, I think I can say that we are understanding things clearly. Can I say that?
Yes, ma'am.
Now, when you complete this in your classwork, you're going to do it again.
Yes, ma'am.
So that way, you know, your retention will be better.
Yes, ma'am.
Okay, over to the next one. So it's multiplication. You have to multiply. It's multiplication everywhere. It's not addition, subtraction. It's multiplication everywhere. Everything you have to multiply. See, now when it is 4x into 3x into x into 2x, what's the answer?
Twenty-four x.
24x power 4.
24x power 4.
Yeah. So what did you do? 4 3s are 12. 12 2s are 24. X into x, x square, into x, x cubed, into x, x to the power 4. But what is 4x plus 3x plus x plus 2x? What's the answer?
8x, ma'am.
8x?
10x, ma'am.
10x.
10x, ma'am.
It's 10x, that's all. It's only 10x. It's 10x. Similarly, here in this question, it is minus 2 into cube root of 5 into cube root of 5 into 3 into cube root of 5 into 4 into cube root of 5. See, like minus 2x into x into 3x into 4x. I'm just replacing cube root of 5 with x so that you understand. I'm just replacing cube root of 5 with x so that you understand. It's like minus 2x into 3x into 4x. So what's the answer? Minus 6 minus 24 minus 24 x to the power 4. So that means you'll be multiplying the numbers and then multiplying the x's there. So here it will be minus 2. It will be minus 2 into 3 into 4 into cube root of 5 into cube root of 5 into cube root of 5 into cube root of 5. minus 2 into 3 into 4 into cube root of 5 into cube root of 5 into cube root of 5 into cube root of 5. So that's going to be minus 24 cube root of 5 into 5 into 5 into 5. That's how we multiply. You can put all of them under the same cube root. So minus 24 from 3 5s, 1 5 out. And the other 5 remains under the cube root. So it's minus 120 cube root of 5.
Yes, ma'am.
I just checked if I've done it in the same way or a different way. So when you look at an expression to be simplified, you shouldn't, some of us will just start working as if we know, we'll just start working. Give some time, stare at the expression, understand the expression. Get the correct idea and then start working. Don't just start working, writing the question and then just doing whatever your mind says. So we multiply the numbers 0, minus 2 into 3 into 4. This one is minus 24, cube root of 3 5s, 1 5 out. This 5 remains under the cube root. Minus 24 into 5 minus 120 cube root of 5. Take a screenshot, children.
Taken note.
Taken, ma'am.
Taken note.
All right. Oh, sorry. No, by mistake, I went to the answer slide. So now you're going to understand something new. You're going to understand how to multiply surds of different order. So now supposing you have square root of 2 and cube root of 2. Sorry, cube root of 3. Supposing you have square root of 2 and cube root of 3. How to multiply these two? How to find their product is what we're going to learn now. So ready? All right. So 5 into 4 to the power 1 by 3 into 3 to the power 1 by 2. Correct? 5 into,
Yes, ma'am.
yeah, this is the first step. 5 into 4 to the power 1 by 3 into 3 to the power 1 by 2. Okay. Now leave 5. 5 is comfortable. Now don't ask me how do you say it's comfortable. It's better than 4 to the power 1 by 3 and 3 to the power 1 by 2. 5 is comfortable. So don't disturb 5. 5, let it be 5. We'll not complicate that. Now look at the other two. 4 to the power 1 by 3. Am I audible and clear, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. So now tell me, look at the denominators. Look at the denominators. 3, 2. What is the LCM of 3 and 2? What is
6.
LCM of 3?
6, ma'am.
6, ma'am. 6.
How do you bring 1 by 3 to the denominator 6?
Multiply 2 on
Multiply 2, ma'am.
numerator and denominator.
Yeah, so this is our third or fourth standard into 2 by 2 equivalent fractions. So 2 by
Yes,
6.
ma'am.
So first step is LCM of 3 and 2 is 6. We need to bring both the denominators. Sorry, we need to bring 3 and 2 to the same denominator 6. All right. Okay. So 4 to the power 1 by 3 into 2 by 2 into 3 to the power 1 by 2 into what should I do?
3 by 3.
3 by
3
2.
by 3.
What is the
3 by
value?
3,
3 by 3?
1.
1. So what is 1 by 2 into 1? 1 by 2.
1 by 2.
Changing the value. You're not when you're multiplying and dividing by 3, you're not changing the value of anything. 3 to the power 1 by 2 into 3 by 3. You're multiplying by 1. So you're not disturbing or you're not changing the value of the expression given. Equivalent fractions. Okay, why did we multiply here by 2 by 2, multiply and divide by 2? Then only 3 to the 6. Here 2 3 the 6. Next step 5 into 4 to the power 2 by 6 into 3 to the power 3 by 6. Don't simplify. You'll go back to the question. If you simplify 2 ones are and 2 threes are, you'll go back to 4 to the power 1 by 3. Don't simplify. If you simplify 3 ones are, 3 twos are, you'll go back to the question. Don't simplify. You should not simplify.
Yes, ma'am.
Yeah. Now 5 into 4 square into 1 by 6. Because 2 by 6 is equal to 2 into 1 by 6. Don't simplify, I said. If you simplify, you'll go back to the question. 2 by 6, 2 into 1 by 6. Into 3 to the power 3 into 1 by 6. Can we proceed? 2 by 6 is 2 into 1 by 6. 3 by 6 is 3 into 1 by 6. All right. Sometimes we have to turn off our videos to eat or drink something. That's completely fine because, we come late or not late. Your school works for longer hours and you return home late. You come home maybe by 5:30, 5:45. There's no time to eat and drink. So it's completely fine to turn off your video to drink something in the middle. But don't keep your video turned on and munch on your snacks or, drink your coffee or tea. It's absolutely fine. You can turn off your video if you have to eat or drink something, but please listen to the class at the same time. Okay, children. So after this, can we go ahead?
Yes, ma'am.
Yes, ma'am.
It's clear.
Yes, ma'am.
So now 5 into 4 square, the whole power 1 by 6 into 3 cubed, the whole power 1 by 6. Why, Prajit, is somebody calling out to you? You've been looking.
No, ma'am. I'm
Okay.
looking at the screen right now.
Okay. All right. Now it's going to be 5 into 16 to the power 1 by 6 into what is this? 27 to the power 1 by 6. Bases are different. Bases are different. Powers are the same. So you can multiply the bases and raise it to the same power. See, there may be slight variations in the answer I have done because anyway, net, both will be, both are correct. I'll explain if the answer slide is slightly different, I will explain that also to you. Bases are same. Oh, sorry, bases are different, but the powers are the same. So you multiply the bases and raise it to the same power. Now I don't know what is 16 into 27. I'm using my calculator. 16 into 27 is 432. Is 432. So 5 into 432 to the power 1 by 6. So it is 5 6th root of 432. 5 into 6th root of 432. 5 into 6th root of 432. This is the product.
Yes, ma'am.
We'll do it again. It's very simple. Take it away. We'll do it again. First step. 5 into 4 to the power 1 by 3 into 3 to the power 1 by 2. First step. 5 into LCM of 3 and 2 is 6. So 4 to the power 1 by 3 into 2 by 2. Then only you will get denominator 6. 3 1 by 2 into 3 by 3. Only then you will get denominator 6. LCM is 6. 5 into 4 to the power 2 by 6 into 3 to the power 3 by 6. Do not simplify. You will go back to the question. 5 into 4 to the power 2 into 1 by 6 into 3 to the power 3 into 1 by 6. 5 into 4 squared, the whole power 1 by 6 into 3 cubed, the whole power 1 by 6. 5 into 16 to the power 1 by 6 into 27 to the power 1 by 6. Bases are different, powers are the same. So multiply the bases, sorry. So multiply the bases 5 into, oh God, I put that again. Okay, 16 into 27, the whole power 1 by 6. Multiply the bases, raise it to the same power. 5 into 432 to the power 1 by 6. So 5 into, or you don't have to put the into sign also. 5 6th root of 432. So see, now we finished it quickly. First, when we learned it, when we had to understand for the first time, it took a longer time. Now we got it. Yeah. Slight changes in working will be there, children. You can just. So here I've written 1 by 6. That 1 by 6 straight away I've written it as. See here. This 1 by 6. No, I've written this 4 square as the base. 4 square as the base. And 6th root of 4 square. You understand this also. And this is the 6th root of 3 cubed. You don't tell me I'm confusing you. You can also do it like this here. 1 by 6, 1 by 6. So 6th root. 1 by 6, 1 by 6, meaning 6th root. 4 square, 3 cube. Then 16 and 27, 6th root. 6th root of 16, 6th root of 27. So 6th root of 16 into 27, which is the 6th root of 432. Maybe you can take a picture of this one also. You can take a picture of this one also. All right, next one. Yeah, try this. It's similar to the, I'll just get you started. I'll just get you started. Yes. So this is 3 to the power 1 by 2 into 2 to the power 1 by 3. So you have to simplify this, you will have to use a similar procedure we used earlier. The LCM of 2 and 3. Do it. I'll also come back in 2 minutes, children. Please work this. Oh, I can see only Sanjay and Sindhu. How sweet.
I have finished the sum.
What's the answer? Prajit, Tanishka, Sanjay, Sindhu, Madhumita?
Ma'am, I got 6th root of 36.
6th root of 26. Huh?
36, ma'am.
6th root of 108. 108. Yes, 108.
Prajit, yes, what's your answer?
6th root of 108.
6th root of 108. Sanjay and Sindhu?
Ma'am, the same we also got, ma'am.
6th root
Ma'am,
of
6th
108.
root of 108.
Tanishka?
Ma'am, 6th root of 36.
6th root of 36. Netra?
6th root of 108, ma'am.
6th root of 108. Krishmika Shri?
6th root of 108, ma'am.
6th root of 108. Okay. Let's see the correct answer. 6th root of 108.
Yes, ma'am.
Very good. Also got it right. Good. Others also, I will not say bad. Well tried. You can just see where you've gone wrong. All right, children, it's time for the next meeting. So we need to wind up the session. Take a screenshot.
Taken, ma'am.
Take a screenshot of this one.
Taken.
Done. All right. Yeah, this one also. Take a screenshot. Similar question, children. Similar one.
Taken, ma'am.
Same idea. Don't get scared of the number. Oh, so large the number is. Don't get scared of the number. Same idea. The idea is the same. And we know multiplication. This is the second question. Okay. So today we have seen all the 12 subdivisions in question number 1. We'll continue in the next class.
Yes, ma'am.
All right, children. Please complete all this in your classwork by the next class. So when the understanding is fresh in your mind, complete your classwork. That will be more beneficial for you. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Okay, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.